In this video, we'll learn the method to find the area enclosed between two curves. Now let's say we're given a first curve y is equal to f of x, as well as a second curve y is equal to g of x, and that we're asked to find the area enclosed between those two curves. Now the first thing you should always do is to make a sketch or a diagram with your graphical display calculator of the two curves. So I'll just make up two generic curves here on an xy grid. Let's say we have a curve, our first curve is y is equal to f of x, looking something like this, and that our second curve looks something like this, y is equal to g of x. Now what we're being asked for here is to find this area here enclosed between the two curves, which I'm currently hatching in green. So how do we do this? Well, the first thing we need to focus on when doing this type of question is the points of intersection of the two curves, which I'm currently highlighting right now. And in particular, what we'll be interested in is the x-coordinates of these 2 points. I'll call those x-coordinates A and B. The way we find those two values, A and B, is by solving the equation f of x equals to g of x. And now we do this, remember, this equation we solve to find A and B. So that really is one of the important steps in finding the area between two curves. Now once we've found A and B, then two cases may arise, and we'll look at both of them. Let's say we have, I'll draw both sketches side by side, x and y, and here I've got my curve y is equal to f of x, and on the second curve we'll have y is equal to g of x. And I'll just draw the second sketch now, x and y is equal to f of x, and the second curve y is equal to g of x. Now, the key thing to notice here is that despite the fact that both of these curves look very similar, or both of these diagrams look very similar, the formula for calculating the area between the two curves will be slightly different in each case. Looking at the first one here, what we notice is that between the two x values a and b, the curve of f of x is higher than the curve of g of x. Whereas if I look at the second diagram that we have here, between the two values a and b, it's the curve of g of x which is above the curve of f of x. Now because of this, to find the surface area between the two curves, the formula will be slightly different. In the first case, we'll have the area is equal to the definite integral from a to b of f of x minus g of x dx. Whereas in the second case, when g of x is higher up than f of x, the area will be equal to the definite integral from a to b again, but in this case it will be of g of x minus f of x. In other words, what we always have to make sure of is that we're always subtracting the curve which is lower from the highest curve. So looking back at the first one here, I can see when I look at this curve, or this diagram, that the curve of f of x is above the curve of g of x between a and b, and so the area between the two curves is given by this formula here. I'm subtracting g of x from f of x. Whereas in the second diagram, I can see that the curve of g of x is higher than the curve of f of x between a and b, and therefore I'm subtracting f of x from g of x between a and b. And there you go. Those are the two formulae that you need to know. We'll be seeing how to use it in the next video.